Now, the leaky rectified linear unit improves upon the idea of the ReLU function by allowing a small non-zero gradient when the unit is not active, less than or equal to 0. So we notice in this negative, right over here, it leaves some extra room. So we got some extra room for negative values. As our input. We see the difference over here, so that's ReLU, it's 0, but here, in this case, we have a leaky ReLU to be able to ensure that when there is a negative value, the slight slope ensures that even the dead neurons, those that only output 0 in ReLU, have a chance to update and contribute during the training process. So the reason for the slight slope is to allow negative values / dead neurons to contribute during the training process. As there is always a gradient flowing through them, so that is why in particular. So neurons, I would say all neurons have a gradient flow through them. Now, to give a breakdown of the symbols for the ReLU, for the leaky ReLU, so we already know that x is going to be our given input if x is greater than 0, and then the following symbol is a small constant for negative values. Alpha typically is set to very small values as well, such as 0.01 to determine the slope of the function for negative input values, and this can be crucial for maintaining alive neurons in the network. So alpha incorporates all possible alive neurons during the training process. And again, feel free to take a screenshot of the following. And so yeah, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.